All right, so in this section, we're going to be working with a practice set of problems, number 15 through 17 in your book on page 208. We've got the data over here. And for number 15, to get started, we're going to be calculating our mean and our standard deviation. So you need to pause the video and go through and create that table and calculate out the values. But before we do that, we just skipped a step. So what did we skip? We did not check our criteria to assess if this is a discrete probability distribution. This will be important. If you look in your homeworks, in your exams, you're going to have questions which will require you to make this distinction before you move forward. So let's take a look at that real quick. Right, so here we go through numerical random variable x and its values are associated with corresponding probabilities. Yes, we can see that going through across each of 0 through 10 is a numerical random variable and each has its own associated probability, so that is good. Here we're looking at where all the probabilities sum to 1. So if you pause the video for a moment, take a moment, go through and check that and see what you get for your sum of all the p of x's. And then turn the video back on so we can check that. And you should have got p of x is equal to 1. So that is also. And our third one is looking at each value of p of x is between 0 and 1, because again, those are the maximum levels for probability. And we can see that is indeed true here. So we are ready to move on and solve for our mean and our standard deviation. So pause the video here. Look at your notes. If you need to go back and watch one of the other videos where we're calculating the mean and standard deviation from a probability distribution and get your answer for these two questions. Pause the video while you do that. And then once you've got your answer, turn the video back on and we'll check your answers together. Okay, you should have gotten your mean of 5.0 and your standard deviation of 1.6. Now, our next question, number 16, is asking us to look at unusual events. In order to answer this question, we're going to have to calculate the usual range, so what's the maximum and the minimum range. And as you can see, you've got your formula right here, so your maximum is literally your mu plus 2 times the standard deviation, and your minimum is going to be mu minus 2 times the standard deviation. So pause the video here. Again, take these numbers, plug them through the formulas to get your own maximum and minimum value, and then once you have that, turn the video back on to check those answers together. Alright, you should have gotten 8.2 for your maximum and 1.8 for your minimum. So our last question we've got here for number 16 is having one girl in 10 births unusually low? So if we're looking at our range, we have 8.2 and 1.8. So how does that work in relation to our question? And we see that it is, in fact, unusual because having one girl is outside the range of the usual events. Notice having just 2 girls would fit within the range of usual events, but having only one is outside the range of usual events. Okay. So now we're looking at number 17. Number 17 is a different kind of problem we haven't worked with before, so let's work through this together with a little bit more detail. We've got 2 components. We're solving for an exact probability, so the calculated probability of getting exactly that event, in this case probability of having 8 girls out of 10 births. And the next one we have is at least extreme. So this is calculating the probability of getting that event or any others at least that high or low. So you need to pay attention to the wording in the questions to make sure you're identifying what you need. If they're asking a question about getting a probability of an event that, or any others that are at least that high or low, instead of solving for just probability of 8, we're actually going to be probability of 8 or more. So we need to use 2 different formulas for this. So looking at this data, let's start with number 8, part 8 up here. And so probability of 8 is going to be what? Looking over at your table, it's going to be 0.044. And that's it. You're done. However, if we're looking at something that's at least as extreme as, we're going to have our probability of 8 or more. So we need to take the probability of 8 and add to it the probability of 9 and the probability of 10. Because if I have 9 girls out of 10 births, I have also had 8 girls within that 9, and so forth for P of 10. So here we're using classical probability theory in the addition rule. So pause the video here, take your probability for 8, you're going to add it to your probability for 9, and your probability for 10, to get your total probability of getting 8 or more girls in 10 births. So pause the video, get your calculation, and then turn the video back on when you're ready to check this together. You should have gotten 0.055. Okay, so that is our probability of having 8 or more girls born out of 10 births. Notice that, of course, that is quite different than just the probability of having 8 girls, which is going to be smaller. Okay, now we're moving on to the next question. So which probability is relevant for determining if 8 is an unusually high number of girls in 10 births? So if we're being asked this question, and you have several questions like this in your homeworks and on the exams, is having 8 girls an unusually high number of girls in births? So think about that carefully and what that question is really asking about. And notice when we're asking about unusually high or unusually low outcomes, we use a probability value to evaluate the particular number of events. If you're calculating if a particular amount is an unusual outcome, do not use the probability of the exact outcome. Again, that having probability of 8 girls is also encompassed within probability of having 9 and probability of 10. So they all are included together. So do use the probability of that outcome and all the others as extreme. So pay attention to the wording in the homework questions and the exams. When it's asking you, is such a value unusually high or unusually low? Do not use just the probability of that exact outcome, but you need to use the probability of that outcome and all others that are as extreme in that direction. So looking here at our question, 0.055 is going to be the correct probability to use for answering this question. Now we're on to part D. So is 8 an unusually high number of girls in 10 births? Explain. So now we have our probability of that, and now we need to assess, is it unusually high? So notice we're taking this step by step. We started getting the mean and the standard deviation. We use those to calculate our range, right? Now we're looking at our probabilities. And we've looked at producing the probability for having exactly 8 or at least as 8. We know that now we're going to be proceeding from when we're looking at an unusually high number, we're looking at the probability of 8 and more all other extreme events. So in this case, probability of 8, probability of 9, and probability of 10. And now we have our last question, is 8 an unusually high number of girls in 10? To answer this question, we need to apply the rare event rule. All right, the rare event rule says the probability of a particular observed event is extremely small, right? Then we're going to say that it has not occurred. So what we're going to use here is our 0.05. So we have 0.055, and then we compare it to 0.05, and we're asking ourselves, is that number less than or equal to 0.05? If it is less than or equal to 0.05, then it is we can say it's an unusually high number of girls in 10 births. If it is not less than or equal to, we cannot make that statement. So here we can see this is in fact 0.055 is in fact higher than 0.05, so it is too large. So this is not an unusually high number of girls in 10 births. And this ends our tutorial looking at the practice problems of 5 through 17. The last section you have for this is looking at problem 18 and working through similar problems such as number 17 again.